Analytical reasoning for today for grades 6 to 8. If you're not so sure about what that is, stay tuned. You'll be given a brief introduction to it as well. Let me give a quick introduction to myself along with that. My name is Srijan Chakrabarty and I'm a teacher expert at Cuemath. I have a teaching experience of 3 years and my subject of expertise is mathematics and reasoning. I teach in India and parts of US as well. Let's talk about the table of contents for the day. First of all, as I said, we'll be discussing about what analytical reasoning actually is. Then we'll talk about the objectives for the day. Then we'll take up some problems, of course, and a few advanced level questions. And finally, we'll look into the learning outcomes. Let me start by sharing a quote. What we hope ever to do with ease, we must learn first to do with diligence. You need to be careful and persistent enough to be able to take up questions on this particular topic. The reason why I'm telling you this is because analytical reasoning is a way of measuring a candidate's comprehension skills and their ability to find out informations, whether it be key information or any partly information, and apply logic and find patterns to anything which is given to them. Suppose you're given a geometrical figure. How many patterns is a child able to find out? All of these things fall under analytical reasoning. Of course, you won't be needing any prerequisite knowledge to be able to do this kind of questions. What you need is persistence, you need to be careful, you need to hard work, and also patience. So, I hope you understood what this is all about. We'll be discussing about geometrical figures and patterns that we'll be able to figure out from these figures. So let's move to our objectives for the day. We'll be trying to find out the minimum number of straight lines required to draw a figure. You'll be given a figure and we'll be trying to find out the lines that we need. And after that, we'll top up, we'll go to a higher level. Instead of lines, we'll be trying to find out the number of squares, triangles, and the rectangles in the given figure. Now, before we get started, let's take up a quick test. I'll be sharing this figure with you. What we need to do is we need to find out the minimum number of straight lines that we'll be needing to draw this complete figure, isn't it? So I hope you try this one out along with me as well, so that you get to know how we're going to be able to do this kind of questions. And of course, I'll be telling you how we'll be starting up with the questions, how we'll be tackling this kind of questions as well. So I hope you are trying out this question as of now. If you look carefully, I need only straight lines, isn't it? So I'll always start off with the boundaries. The red lines here comprise of the boundaries that are given to us, and later on I'm going to draw this line as well. I hope you can see how many lines I drew. There are a total of 8, so let's add 8 plus I have a few more lines to be added to this figure as well to make it complete. So let's try to join this inner boundaries. I have a square here, so 4 lines, and then again I have this straight line. So I hope you got the answer to this question right now, isn't it? I have 8, then I have 4 more, and I have one last line. I have 13. I hope you found the correct answer to this one as well. But don't worry about it. This was just a quick test to see your understanding. We'll be moving along the actual questions right now. But before that, let's talk about the applications of analytical reasoning. First of all, at work, people use analysis to scrutinize speech, which literally means to find out information from speech, documents, diagrams. You are always given with charts and graphs. And what do we do with those things, with those figures, is that we try to find out relevant information that is needed for our network. Sometimes recruiters also use these analytical skills to test their employees, as in how good their skills are, their deductive and inductive skills. Of course, you'll be needing all of these skills in problem solving and reporting. So let's take up the first question right now. And you can see that the first question is based on the minimum number of straight lines required to draw the figure. Now the pattern is we'll be taking up a question, we'll be trying to solve it. And as you remember from the objectives, this is the first one. So we'll be dealing with, let's take up the first question, and along with that, the diagram and the options present to us. We need to find out the minimum number of straight lines required to make this given figure. Now let's try to impact these two words, minimum and straight lines, right? So we need to make sure that the lines are straight, and also that we are considering the minimum number of straight lines. The first thing we'll do is that we'll try to look into the boundaries, and we'll try to find how many straight lines are needed for the boundary given. Let's count them up. I have one, I have two, I have three. I think you might be confused with whether I should include this one or not. If you are confused right now, don't worry about it. I'll come back to that soon enough. I have one, two, three, then I have one more, four, five, and six, right? This more or less takes care of the outer boundaries. Now we'll try to look inside of the figure given to us. Before that, let's try to jot it down. 6 plus, we'll try to add them up soon. Now, let's look into the straight lines which are inside of the figure. I have one of this, isn't it? Then again, I have this, which is the second one. Similarly, I have two over here as well. So that gives me a total of 4, isn't it? And then you can straight up find out the number of lines that we have. 5, 6, 7, 8, 9, and finally 10. But wait, you need to make sure that whether you are considering each and every line or not. And in here, we didn't consider one of those, isn't it? Which is this one, right? So if I consider this to be a one straight line, I think it helps us to reach the criteria of minimum number of straight lines. So finally, how much will we have? I didn't write the number here, of course, but I think you were able to figure it out. Initially, we had 6, now 7, 8, 9, 10, 11, 12, 13, 14, 15. I think it should give us a total of 17 right now, isn't it? I hope you're able to figure out the answer to this one. Let's try to look into the next question right now. Again, we have a question in which we need to find out the minimum number of straight lines. Again, we'll try to find out the number of straight lines we need to form the boundary. I have 1, I have 2, I have 3, 4, 5, 6, 7, isn't it? Let's jot that down. 7 of them make up the boundary. Now let's talk about the number of lines I need inside of the figure, isn't it? So if I look carefully, I have 1, I have 2, I can consider this straight line to be 1, 3, then again the same to this, 4, 5, 6, and then again 7. So We were able to find out 14 of them, isn't it? And if you look into the options carefully right now, you can see that I have 14 as one of my options. And that means that B probably should be the answer to this one. I hope you understood this one because I want you to try out this one by yourself. Of course, you are advised to take it up and you can match your answers with mine and see whether it's matching or not. Here are the options for you as well. So again, we'll try to jot down the boundary, the total, oops, yeah, the total number of boundaries that we have. 1, 2, it's a rectangular figure, isn't it? 3, 4. It's just like it's almost similar to the figure that we have, right? 5, 6, and 7. Yep, the 7 lines, straight lines, make up the boundary. Let's try to look into the lines that are inside of this figure. Now you can see that this whole straight line, you can consider it to be a one line over here, isn't it? Similarly, the same thing happens here. Of course, if I join these two, I get a total of 4. And then, of course, the minimum number of lines over here, 5, 6, 7, and 8. You have a total of 8 lines here, don't you? So if I add them up, I get 15 as the answer. One more thing you can do in this kind of cases is that you could see that the inside figure, the blue colored figure, which we have inside of the given figure, it's actually symmetrical about this line, isn't it? So if you just find out for one of them, you can find out for the other half as well, but be sure that you don't miss the line itself which you are taking symmetrical. All right, this is another way of doing this kind of questions, and I hope you're able to figure out the correct answer. With this, let's try to look into the next question. We'll now look into our second objective, which is counting the number of squares, triangles, and even rectangles in a given figure. As you can see, you're given a figure and you're asked to find out the number of squares in this figure. The options are also given to you, and if you look carefully, you can see that, of course, you can spot a few squares out there, but there's a way in which we are going to approach this kind of questions. It's almost similar to the ones involving the the minimum number of lines. So what we'll do in this case is that we'll try to look into the bigger picture. We'll try to look at the most outer square presented to us. So if you can look carefully, you'll see that we have one square over here, isn't it? Okay, so that's if I consider the whole thing as one. But now inside of it, we have several more squares out there, correct? You can see that, you can spot that I have one small square here and another one over here. And similarly, if I follow the same trend, you can see that I have a total of 8 smaller squares present, right? That is because I'm only considering one of the components inside of this figure at once. One of the components as in the one of the squares, the items inside of the figure as one. Let's try to note down the numbers that I have found. 1 plus 8 for now. Okay, now let's try to figure out if we can find out any other squares presented in the figure. One thing you can observe is we took one component, right? We took just one component for this one, isn't it? So let's try to take more than one component, but that won't work in case of a square, isn't it? But what about this? Can I consider this to be a square? Similarly, Can I consider this to be a square? If I have two squares here, doesn't that mean I'll have two squares here as well? Okay, so I get a total of 4 squares now, isn't it? Let's try to note that down as well. Okay, now since I'm done with this 4 squares, do you think there's one more square hidden in between those two? If I join the squares, okay, if I partly join the squares, do you think I will be able to get, sorry for that, I'll be able to get one more square over here? Will that do? Okay, so instead of 4, should I be writing plus 2 now? How many do we have as of now? 8, 10, 14, 15. I have a total of 15. Of course, that is one of the options out there, but as I told you, we need to be persistent and careful. We forgot about the inner square present to us in the center. Shouldn't we be focusing on this as well? This inner this inner square. So if I add to this as well, do I get 16 as the correct answer to this? So what we did here is that we looked into the figure as a whole, and then we tried to find out the number of squares present inside of the figure only. If we do that, and if you're careful with that, we'll be able to figure out how many squares are actually there. I hope you got this one, because we'll take up one more question now again. This time we need to find out the number of triangles in the given figure. Here are the options. Now I'd like you to try this one out with me as well. We'll follow the same approach again. So the first thing is, if I can consider this outer triangle, isn't it? That gives me just one. Of course, it's just not one. We need to make sure that it matches the options as well. So of course there are more present out there. If if I if you look carefully, if I just draw this line, it divides the triangles into two parts, isn't it? So I have two more triangles inside of this. But what if I didn't actually do this, but I drew this instead? I would have got two different triangles again. Similarly, if I do it with the third one, I get two more again. So if I consider all of this, will I be getting a total of 6 different triangles? I hope you understood this part. If I do get 6 different triangles, now we'll look again into the triangles that we found, okay? Of course, now you can divide these triangles again, considering this point of intersection as the center, right? Can we divide this further into three different parts? Looks a bit equal, but not gonna say that. Now, since we have divided into three different parts, we have 3 triangles present. And along with that, if I divide it further, just to show you how it looks like, let's remove that. If I divide it further, can you actually see a total of 6 different triangles? 1, 2, 3, 4, 5, 6. Can you see a total of 6 different triangles? So along with these 3, if I join these 6 different triangles, am I getting the answer that I need? 6, 12, 13, 15, 16. I get 16 as the answer. I bet option A should be the correct one. If you are getting the correct answer as mine, you're going on the right track. Congratulations. So with this, moving further, let's try to find out the number of rectangles in this given figure as well. Now this one might be a bit tricky, but I wanted all of you to try this one out again with me as well. Now if I look carefully again, we'll follow the same trend. We'll look into the number of rectangles that we have. First of all, we'll consider the whole thing as one. So I have one rectangle out here. I'll note that down later. But again, if I look into this rectangle, I can separate it into two different parts, isn't it? One and two different parts, right? So I have one rectangle, and I have two rectangles again. Sorry if I was saying triangles. Spread it out. I have two rectangles as well. Now, if you look carefully again, will you be able to divide it into two parts again such that I get a rectangle? So again, that gives me two more, isn't it? But the two parts that I found out, can I join it again? Can I join it and then make it to be just one rectangle? Understood? So I get 2, 3, 4, 5, 6. I get 6 right now, isn't it? But if you look carefully, none of the options are 6. Many of you might have made it wrong if the answer would have been, if I had an option called E and I would have had 6 in it. Many of you would have clicked on 6. But we need to look into the bigger picture again. What if there are more rectangles present and I'm not able to find them? Do you remember that every square is a rectangle? So if I consider the two squares present here, which looks like squares, of course, but we all squares are rectangles. So does that give me an extra two rectangles out there? And thus we do get the correct answer to it, isn't it? So as always, remember to be careful and persistent with the questions. If you found out the correct answer, congratulations to you. Let's take up the next question right now. I believe this will be the last question, and after that we'll be taking up one advanced level question as well. We need to figure out how many triangles, let's emphasize on that, how many triangles and squares are there in the given figure. Let's look into the options present to us. Now there's one more thing I wanted to let everybody know, is that we can see that there's some similarities in the options. Both of option A and C has 7 squares, B and D has 9 squares. So I'm going to deduce it a bit. I'm trying to decrease my chances of finding out the correct answer. Sometimes if you are not quite sure about how to approach a question, this can be one way as well. So the first thing I'll do is find out the number of squares that are present to us to eliminate two of the options, of course. If we look into the figure carefully, of course, you'll be able to figure out 4 squares present there, right? 1, 2, 3, and 4. Great. We were able to find out 4 squares from the figure. But are there more? Do you think you'll be able to find more out of it? For that, you need to look into the figure carefully. For this, we need to take two of the components or two of the squares together. For example, if I take this, I'm taking these two squares, I'm taking parts of the two squares and making it as one. Similarly, if I do that to the others as well, I'm getting 3 squares out of it. After I plotted them down, do you think you can find out any other squares out of it? I'll give you a while to think about it. But if not, we were able to find out 7 up until now. If you are able to find out more, will you be able to? I don't think so that there will be any of those over there. We have found out the number of triangles or squares, sorry, we have found out the number of squares that we need, which is 7. So of course I'm going to know that the answer might be in between these two, and the last thing that I need to find out is the number of triangles given to us. Of course we'll be able to plot two of the triangles over here. It's easy to look into, and here is 1 and 2, two triangles up until now. So that means the other triangles that we need to figure out are of course hidden in between those 4 squares. So let's draw a square. And then what we are going to do is we're going to draw a diagonal here. If I draw one diagonal, I get two triangles from it, isn't it? But if I forget about this and draw the other diagonal, I again get two different triangles out of it. So I get a total of 4 triangles out of it if I draw the diagonals. And if I draw the diagonals together, there I get 4 smaller triangles as well. 1, 2, 3, 4. So in total, do I get a total of 8 triangles from a given square? If I get 8 triangles from a given square, since there are 4 squares, will I get a total of 32 squares? Sorry, 32 triangles added with the 2 red triangles, which gives me a total of 34. But those aren't matching the options. It means that there are more triangles that are left to be found out. Can you look into the figure and find out the triangles that we need to spot? Again, this topic is all about finding the pattern, so we'll have to look into the figure very carefully. Now if we look into it very carefully, you can see that again, if I join two squares, I can see a triangle out of it, isn't it? Similarly, if I join these two, again I have one triangle. But look, I have one over here, I have the second over here. Will this be the third triangle? So in this way I'm able to find out 3 triangles. But what if I draw the triangles upside down? What if I draw the triangles such that I have one here, one here, one here, and one here? So I'm drawing it upside down, isn't it? Let's try to draw it. Let's try to add some more clarity to it. Of course, none of those figures match, and I can see that there's one triangle formed here, another triangle formed here, and another triangle formed here again. So in total, do you think there are, not here, a total of 6 triangles that were formed, and that gives us a total of 40, isn't it? That is indeed one of our options, and hence that should be the correct answer. I hope you were able to deduce this one. Let's now move on to the last question that we have. We need to find out the number of parallelograms in the given figure. Now, since this is an advanced level question, you need your time to think about what the answer can be. Also, here are the options available for you. Now, we'll try to do it just like we did the others. First of all, we'll try to mark the outer parallelogram. Just one, isn't it? I have one. And if you look individually at each and every item out there, each and every smaller parallelogram, you can see 8 of them, isn't it? So that means if I just take one of them at a time inside of the given figure, I have a total of 8. So let's write that down. 1 plus 8. Now what we'll try to do is that we'll try to take 2 of the components, 2 of the singular items at the same time. Let's try to take this up. I get 1 from here, isn't it? Similarly, since it's completely identical, I'll have the same figure 4 times, correct? I'm looking into it horizontally. That's the reason why I'm able to figure out the answers. I'll be looking into it vertically as well soon enough. But horizontally, I can see there are 4. But what if I join these two again a bit? There are other components again, right? What if I join these two components or items? This again gives me 1 over here, and this again gives me one of them over here, right? So in total, do I have six of them as of now? Now again, if I look vertically, you can see that I have 4 of them if I take 2 of the items together. So let's note that down as well. If you are finding it confusing, where are the 4s? Here they are. I had 1 over there. This is the other one. And this is the third one. I have the fourth one. So in total of 4 of them. Let's get rid of that. So remember, right now we are taking just 2 of those items together. We'll be taking 3 at a time, and we'll be taking 4 at a time as well. So I had 6 and I had plus 4. In total, I have 19 as of now. Now, I need to take the figures. I need to take 4 of the components at a time. If I do that, I can consider this whole parallelogram to be 1, this whole figure to be 1, and this whole part to be 1. I get 2 out of there, isn't it? Similarly, if I consider this 4 together, and again this 4 together, I have 2 more. What you need to be very careful about is that whether you are adding up the same parallelogram again and again. You need to make sure you are not doing that to avoid mistakes. So let's add up here. I had four of them, right? So 19 plus 4 gives me 23 as of now. I took the whole as one parallelogram. I took individually. I took all the items inside that, all the parallelograms inside that individually. I took 2 at a time. I took 4 at a time. I found the answer to be 23, but I'm still left to be taking 3 of the items at a time to make a parallelogram out of it. So again, if I look carefully, I can take 3 parallelograms here, right? 3 of them together will make 1. Similarly, here also, I will have the same thing since it's identical. I made the parallelograms from this side. Will I have 1 from the other side as well? Let's try to draw that. Here should be the other one as well. Similarly, since it's identical again, I'll have 1 here. So I do get 4 parallelograms out of it when I take 3 of them at a time. So I took 1 of them at a time, I took 2 of them at a time, I took 3 of them at a time, and finally I took the whole figure as 1. So if I add 4 to this, I'll finally get the answer that I need, and this is presented in one of the options. I hope you were able to follow through with this discussion over here, and I believe that this is the last question out of it. So let's move to the learning outcomes that we have gone through in this session over here. The first and foremost thing is that you need to observe the figure carefully, and you need to count them separately as well, like we did in the last question. We took one as a whole, then we separately added them. We need to do these to be able to correctly identify different figures that may be available. The next thing is we did combined figures to find out a given figure. Just like in that example, if you remember, we combined two squares to find out a square out of it, isn't it? So remember, you need to combine figures to be able to find out the given patterns. Also, you need to count them separately, and you need to make sure that you are not taking all of them at the same time. If you do follow these steps, you will be arriving to the correct solution. Remember, diligence is what is the most important in analytical reasoning. Finally, I'd like to give an announcement again that Cuemath is offering is actually conducting the India's biggest maths Olympiad, and we will be having it at the end of November. So if any one of you hasn't actually registered for the event, you can do that with the help of the district. In the description box, the link is given to you. You can find it out and you can register yourself. The fees is only 200 rupees. You will be getting practice materials to help you out with the Olympiad, and also the most important thing is that you'll be getting the experience, which is very, very important indeed. I hope you had a good session. That will be all for today, and I hope you stay tuned for the updates as well. Thank you so much. Farewell.